Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutiwa Sos Ugobela Wemets. And without any further ado, let's look at this question that we have here. Okay, so it says a box of weight 55 Newton. So we are given the weight there. Is suspended from the ceiling by a string. A horizontal force is then applied to the box to keep it in equilibrium when the string makes an angle of 30 degrees with the ceiling. The tension in the string is T, right? Then we are given the diagram like that. 2.1 says explain what is meant if the box is in equilibrium. So what we understand by that is that all the forces there will now be balanced, since we are told of the horizontal force, which is the equilibrium, keeping all these forces in balance, right? So what we understand is that if we say that the box is in equilibrium, we know that the forces will be balanced, but most importantly is that we know that the resultant of the force will now be equal to 0. So what we understand by that is that the resultant of the force is equal to 0. As a result of all the forces being balanced. Then 2.2 says, draw a closed vector diagram of the three forces T, F, and W by using the tail to head method. Clearly label the three forces and the relevant angle. Right, so we know that the W here comes from the weight, so that's our weight, which is obviously going downward. Remember, we know that weight is always acting downward, right? And then now, in order to draw that, we need all these three forces, but then we do understand that a closed vector diagram is actually a right angle triangle. This is the right angle triangle that we get if we say that our system is in equilibrium, right? So we have this. So this will be indicating our W. So remember, we are using the tail to head method. So this is our tail and this is the head. Now, the force will be starting here from the head of the W there, the weight. And then this is the tail. We have our head. Then we label this force. So you just simply take your forces as they appear. So we know that W is going downward. So it's more like a cut and paste thing. So you take this and then you draw it like that. You take this exactly as it is. You draw it horizontally like that. Now look at T. T is diagonal like that. So we're just going to start it from the head of the force there. So and then going all the way to the tail of W there. Right, and then this is our tail like that. So now this is TWF, and then the relevant angle, note this, guys. If we want the angle in here, note that it is not equal to 30 degrees, because when we took this, note that this angle is outside here. So the 30 degree would be somewhere here. Now, if this is 30 degrees, what is the angle in here? Now, obviously, you do understand that if this is all 90 degrees, you need to say 90 minus 30 degrees. Then this is 60 degrees. So the angle inside here, the relevant angle that they're talking about, should be 60 degrees. Right, so that's how you should be indicating that. So your closed vector diagram would look something like this. And then just like that, you have your 3 marks. And then also don't forget that your weight is 55. So you can show it here. So this is 55 newtons. Now, 2.3 says calculate the magnitude of F and T. So we have seen that we have our weight here is 55 newtons. And now we are looking for the magnitude of tension and the magnitude of the force. Now, how can we calculate that? We do understand that if we say that this is a right angle triangle, then we can use SOHCAHTOA, right, in order to find the other two missing sides, right? So to calculate the magnitude of force, we can simply use the trig ratio tan. This is tan 60 degrees. And then we do understand that this will be opposite over adjacent. Right. So what is our opposite side? That's F. And then what is our adjacent side? It's our weight, which is 55 Newton. So to calculate the force, we would need to say 55 and then tan 60 degrees. Right. Then all you need to do is punch this into your calculator, and then you get a value of 95 0.26 newtons. Right. Then now, how would we calculate the magnitude of T? We can also use the trig ratio cos, right? So if we say cos 60 degrees, note that this will be adjacent over hypotenuse. So our adjacent already is 55, that's our weight, but then our hypotenuse, that's tension. So to calculate this, we would need to say T is equals to 55 over cos 60 degrees. Then our tension is 110 newtons. So that's how you were supposed to tackle this question, guys, for a total of 9 marks. So please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.